Hi everyone, welcome back to GridPro. In this video, we continue our series on how to mesh ice accretion features using GridPro. We've already covered C-grid topology generation for a clean airfoil without icing, using the nesting feature to modify the enriched clean airfoil topology to accurately capture icing features. If you haven't watched these videos yet, check the description for the links and start with the first video for better understanding. Today's video acts as a bridge between our first tutorial on topology generation and the second one on using nesting to capture icing features. We begin with a C-grid topology for the clean airfoil. Find link for the video in description. First, let's replace the clean airfoil surface with the airfoil containing icing features. As the icing airfoil is made up of multiple surfaces, we will load them individually and delete the old surface. Since the icing geometry is topologically similar to the clean airfoil, we can utilize the existing topology to accommodate the icing details. Assign the corners to the airfoil surfaces. The topology has 160 blocks, as can be seen from the validity check. The topology is medium singular, as more than 4 edges are emerging from a corner assigned to the surface. Let's run the grid smoother to examine the grid quality. Although we have a zero-fold grid with a maximum skew of 0.67, the curvatures of the icing structure are not captured well. To improve this, we need to slightly modify the topology at the concave region between the icing and the airfoil. To locally refine the structure, we will use GridPro's Enrich feature. The Enrich tool creates an internal wrap around the selected topology corner, improving feature resolution and enhancing local refinement. First, we will create an internal wrap on the sheet going from the ice airfoil intersection region to the outlet. We will use the corner creating 3-point singularity for compact enrichment. Group this corner in a corner group and apply enrichment with a value of 0.2. After repositioning the corners, we can see the internal wrap structure forming around the selected corner. Density can be increased in the wrap layer to capture the region better. The topology has an increased block count of 179. Now let's run the grid smoother again to check the resulting grid. This time the grid captures the icing feature more precisely. The max skew has now improved to 0.60. We can create an internal surface to capture the sharp trailing edge of an airfoil more precisely. Open the surfaces in the newly launched UI within the same working directory. We need to create surfaces extending from the airfoil's trailing edge to the domain. For that, we will take the corners of the intersection of two surfaces forming the airfoil. Put the airfoil surfaces in the Surfaces group. And use the Intersection of Surfaces tool on the group surface. It will generate the corners at the region of the intersection of two surfaces. Let's put the corner generated at the trailing edge into the corner group and fit the work plane to it. Drag the work plane outside of the domain and copy the corner to the work plane. Group the edges in the corner group and use the Convert wireframe to surface. The internal surfaces will be created by the given name, which can be loaded in the same UI in which topology is present. Similarly, we can create two other internal surfaces and load them. Please refer to GridPro Tutorial 1, airfoil.pdf located in the GridPro, doc, WS, tutorial, medium folder, or access it directly from the UI under Documentation, Tutorial, Medium Tutorials, Airfoil to learn the rules for internal surface creation. The internal surface orientation should be set as interior with auto match. Assign the internal surface to the corners representing them. After running the grid smoother and updating the grid, we can see that the trailing edge is captured more precisely compared to the grid without an internal surface. From here, refer to video 2, where we demonstrate how the nesting feature further refines the topology by locally modifying the block structure. We hope this video series helps you effectively modify the topology to better capture icing features on the airfoil. If you have questions, feel free to contact support at gridpro.com. Thanks for watching.